using the data language and providing internationalization. In this nugget, we're going to talk about what to do if you've got a script that you need to support multiple different spoken languages. A script that needs to have prompts that appear correctly in English or in German. So we'll start by looking at some of the localization options that are offered. And there are really two major techniques that kind of come into play in Windows PowerShell version 2. The first is called data sections, which we'll look at, and the second is called here strings, which we'll also look at. Finally, we're really going to look at making this functional and practical and feasible and less of a pain in the neck. So we'll kind of combine those techniques, and we'll create an infrastructure or create a framework that you can use for a couple of different situations. You'll probably wind up seeing about two different main techniques that you'll choose depending on your exact circumstances. Now, I think the easiest way to probably do this is just to start with a basic script like this one and then walk you through some of these internationalization and localization and blah 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 other stuff. So here's a very basic script. The really important thing to look at here is that I've got three prompts or strings. Enter computer name to check, the following network adapter configurations are on computer, and network adapter configuration inventory complete. What the script actually does, not so important. What we're really interested in here is the idea that if I wanted to share this script with a colleague in Germany, he or she might have trouble reading the English translation. If I wanted to then share it with some colleagues who work at our Japanese office, they might have some trouble reading this English phrasing. So the purpose of the data language and internationalization is to make it a little bit easier to write a script that can be represented in many different languages. And the basic goal is to separate the text strings like these from the program code. In other words, this is functional part of the code here. A variable name, a commandlet name with a parameter. That's never going to change. That's going to be the same on any Windows system anywhere in the world. What we need to separate are these things that might change from country to country. Now there's a couple of things that can kind of help you do that. So let's look at the first little step here. Now I'm kind of faking a couple things out here. There's no built-in module in Windows called prompts module, so don't try and import that and think it's going to work. This is a module that I actually made up, and it contains a function called getPrompt. So we're going to see how that all comes together in a second. But this is a script that I've halfway converted. You can see I've got the same basic 5 lines of code here, and I've replaced 2 of the prompts. I haven't gotten to the third one yet. And the way I've done that is with the data section. And I've created a data section called prompt computer, and it simply outputs this string. So instead of having that string hard-coded down here with the actual program code, I use this special variable prompt computer. And that matches the name of the data section. Notice that there's no $sign up here in the name of the data section. It only gets a $sign when I go to refer to it later. Now, you might just ask, well, okay, if it's going to be this easy, why don't I just make a $sign prompt computer equals enter computer name to check? Why do I have to have a data section? Well, there's a couple of reasons. First of all, one of the reasons you use these sections like this is because it gets all of your strings into a single section of your script. These things have to be defined before they can be used, which means they're going to wind up being at the top of your script. If you were giving this script to a translator, it would make it easier for them because all of the strings would be consolidated into a single area. The other reason you use a data section instead of just variables is because data sections support a restricted set of the Windows PowerShell command language. Within these curly braces, within that script block, you can use all operators except the dash match operator. So you can use dash equals, dash greater than, whatever else. You can have if, and else statements. There are certain built-in variables that you can utilize, and you can only use these variables. $true, $false, and $null. Interesting. Most importantly, 2 built-in variables, $culture and $UI culture, allow you to access the language setting or culture setting of the current computer. So that lets me determine if the current computer is set up to run English or Japanese or German or Spanish or anything else. You can put comments in here so that you can indicate to a translator what the prompt is supposed to be for. You can have pipelines, you can have multiple statements. Obviously you can have literal string values like this one here. You can have a very small list of specific commandlets, but if you, as I've done in this second data section, if you use the -supported command, you can enable the use of other commands and functions. And in this case, I've enabled the getPrompt function, which I defined in my prompts module. That allows me to, within the data section, execute getPromptStart. Whatever gets returned by that will become the prompt for prompt start and will get inserted here in this right host. So you can kind of build your prompts in different ways. Now, having shown you the data section here, again, this is only a partially completed script. Let me kind of take you all the way and show you this version. Well, we'll get there in a second. I first want to kind of introduce you to the concept of a here string. And that's what this @quote @ means. This is a string, sort of a block string. Everything here, everything that falls inside of those two marks is considered part of this string data. Now, there are some really specific guidelines around how this works. The @ has to be on a line, and then it has to be followed by a carriage return. Your actual string data starts on the next line. When you close it, the @ has got to be on a line by itself, and it needs to be in the first column. In other words, look what happens to the color coding if I indent this. See, it all goes wonky? That's because in order to close the here string, it needs to be right there. And it's not until it gets back in that position that it fixes it. So all of this is one big block of string data. There's a commandlet called convert from string data. It will take that here string as string data and take these as key and value pairs. Now note, you do not put quotation marks around these things. You don't do this. And I'll show you why. I'm going to leave that there in a second. I'll show you why you don't need to do that, but you don't. So all of this gets converted into a hash table and stored in the $strings variable. And here's how you access it. $strings.computername gets me this value. $strings.start gets me this. $strings.finish gets me this. So remember I told you don't need these single quotation marks, right? All right, so let's run this. This is why you don't need the single quotation marks. Everything in that here string is taken literally. So if I say localhost, I spell it right, localhost, their network adapter configuration complete, and there was the beginning of it. The following network adapter configurations exist. So the reason you don't put these here is because they're taken literally, and they're not needed. So I've kind of shown you two different things now. I've shown you this data section, and I've shown you this string data here string technique. Now I'm going to combine the two. This here is useful, but here's the problem if I go to translate. Let's say I give it to somebody and I want it to be translated into German. They're going to translate all this into German. So now I've got one version of my script that's English, and another version that's German, and another version that's Spanish, and another version that's French, and another version that's Japanese. And if I have to come down here and make a change to the code, maybe I want to add a filter. Now I have to go change 50, 11 dozen million scripts, even though they all have identical program code. The only reason I have separate scripts is because of this language. So ideally what I want to be able to do is include all of the languages in a single place, and that's what this does. This brings the here string concept together with the data section. So here's what I've done. I've created a data section just called prompts, and I need to spell culture correctly. Culture. Culture. What this is doing is, remember I told you within the data section you can access the if else if structure, and you had a few built-in variables, one of which is $culture. So if $culture equals en-us or US English, then I want to convert from string data, and rather than putting my string data into a variable, I'm just putting my here string right here. Else if the culture equals DE Deutsch German, then I'm going to convert from string data and get this. Because this $culture variable is automatically created by PowerShell and populated from the operating system, I don't have to do anything. If my script finds itself running on a German system, then these are the prompts. If it finds itself running on an English system, then These are the prompts. Now, you might want to have a default, so you could certainly have an else section. And maybe you would put a copy of the English US down here, or whatever language you want it to be the default. So you've got a couple of cool things that have happened here. I've still got all of my translatable data centrally located in a consolidated location. It's much clearer what language each one goes for. At least if someone's an experienced translator, they're used to seeing things like EN, US, and DE. I've got all of my languages in one place, so if I need to go make a change to the code in the script, I just go down to the code and make whatever change it is I needed to make. I don't have to go change 5 different scripts, and I don't have to touch the string data. So my functional code is separated from my display strings, and I'm getting to the things in basically the same way, only instead of strings, this would be prompts, because that's the name of my data section, prompts. And so this is going to return that hash table as the result of prompts. So it's very clear and straightforward and easy to work. Now you'll see some examples, I think, where people, I'm going to copy and paste this into a new script. You'll see some examples. Even in my book, Windows PowerShell version 2 TFM, I think we did something like this. And then, of course, you would have the same prompt codes here. And then you would also need to change them in the script. This is not a great idea, because as a programmer, if I come along and I start to look at this, and let's say I've got 15 languages stacked up at the beginning of my script here. So I'm down here looking at the program code. Okay, we're going to read host prompt 1. I have no idea what that's asking for. So we'll go up and look a little bit. Oh, it's asking for Geben Sie den Namen. It's the computer name that I want to check. Okay. I like this a little easier only because the prompt name kind of corresponds to what the prompt is actually asking for. You might even be more specific and call this like start message. So it's clear it's not asking for something, it's just some sort of info message. And you can probably come up with your own naming convention. Maybe message underscore start, message underscore finish, so that you can kind of tell when you're looking at the code what the prompt actually is. Now, this is great. I like that everything's centralized. I like that it's all in one script. I don't have to have multiple scripts, but it's a little bit of a hassle simply because so much of my script is being taken up with prompts. And there are cases where you turn a script like this over to a translator, and even though you've told them, only modify this, don't touch anything else, just modify this, they come down here and start going, oh, well, in German, read is whatever, or Spanish, get, and they start translating your program code because they get a little carried away or they didn't understand the instructions or whatever else, and they wind up messing up your script. So they kind of go too far. So the next step you can take is to actually take this language stuff and take it out of the script file completely. And here's what that looks like. I'm going to start with a prompts section. This is what I get when I paste things in and out. Prompts. So I've got a prompts section that's setting up a culture for ENUS. This comment here is mandatory. You got to have that, because you notice I don't have an if-then statement. What I also need to do is create additional language files elsewhere. So the reason English is in this file is English is my default. If it's running on a Spanish system and I haven't provided a Spanish translation, then it will default to English. So that's why the English is still included inside the script. What you then do is go create separate files. So within the same folder that contains my PS1 script, I need to create a folder called DE because this is the German translation. This file is going to have the same name as my script, but instead of a PS1 file name extension, it's going to be a PS1D, and that's data. And I create a new prompts section, tell it that this is the DE-DE culture, and here are the prompts. So when I run this script, PowerShell sees this. It'll go, I'm not running on an EN-US system. I'm running on a DE system. So I'm going to go and see if there's a DE folder, and if it contains a PS1D file name with the same name as the script, and I'll look, it does. And so I'll load the prompts from that instead. So this lets you get your translations completely out of the script. You could create this file in the beginning with the English prompts, pass it off to an English to German translator, and just tell them, just adjust the stuff that's in brown. There's really not much else. I mean, if they accidentally tried to convert from string data to German, it'd be easy enough for you to fix it. There's really only one command in here and a couple of keywords other than that. So it makes it a little bit easier also if you've got different people who are going to be working on the translation. Maybe the person who's going to be doing the European languages is different from the person who's going to be translating your Asian languages. And so you can get different files off to different people so that they can each kind of be working in parallel. The downside is that my script is no longer standalone. If I want to transmit a complete copy of the script, I need the script and all of these subfolders and PS1D files. So it does make it a little bit tougher to move the whole thing around. My recommendation is, if you're going to do this, that you package the thing as a module, because a module is already going to be in a self-contained folder. You can just put it all in a zip file. It'll have all the subdirectories and everything else, and then you can just move the thing around however you need to move the thing around. And we'll be talking about how to create modules in nugget number 13. So you'll kind of see how bringing multiple supporting files like this is a little bit easier to do when you package your script as a module. Alright, so let's just quickly kind of review the path we took. We've got a plain script that has built-in strings. Downsides is that if we go to translate this, we have to make a different version of the script for every language, and the translator has to know that they can only touch this bit and that they shouldn't touch any of the other bits. Then we went with this. We broke the prompts out into separate data sections. This consolidates them, but it doesn't provide us a way to have multiple languages within the script. So we still have to have different scripts for each language. The neat thing about the data section is that it does allow us to run code and do comparisons. Now here's a similar technique where we've put our string data into a here string and then converted that from string data into a hash table. So that lets us refer to our prompts in a nice sort of standardized fashion like this. And it does keep all of our translatable strings consolidated into a single area, but we would still have to have multiple versions of this for each language. This combines the two techniques. It takes the data section and uses an if statement. You could also have an else for a default down here, but it uses this construct to determine what the local language is on the computer and to provide matching prompts accordingly. This gives us multiple languages in a single script file, and it consolidates all of our languages into a single location. This is really my favorite. The downside is that if we've got multiple translators working on the project, we kind of have to let this file go round robin between them. And there's still a chance some of them are going to get a little overzealous and come down here and start messing with things they shouldn't. So this is the last step. We use sort of a specially formatted data section and the convert from string data so that our script only needs to contain our default language. We then have separate files in a fixed predetermined directory structure, and each of these files contains a separate language. This kind of separates the language from the code completely, so there's really very little that a translator could mess up in here code-wise. It also allows multiple files to be sent off to multiple different translators who can work in parallel on different languages. The downside is that we then have to distribute all of these things along with the script, which isn't so bad if you start packaging things in a module. In this nugget, we've looked at the different options that Windows PowerShell offers for globalization or internationalization. And primarily that comes through the use of PowerShell's data language. The data sections and the here strings combined with commandlets like convert from string data or import the data section. By combining those techniques, you've found a way that you can have a single script that contains translated prompts for every language you need, or a more expanded formal structure in which each language's prompts are contained within a separate file. I hope this has been informative for you, and I'd like you for